Hi students, welcome to this new video where we will present to you some important facts about determinants that you need to know. So if we consider a matrix like this, right? And then we consider another matrix like this, and another one like this, zero, 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 zero. Okay, so we call this matrix this one, and we call it an upper triangle or upper triangular matrix. The estimates here are scalars and numbers, and we call this the lower triangular, and then we call this diagonal matrix. Now, now a square matrix is called upper triangular if its non-entry all lies above the diagonal, right? If it's non-zero entry, all lies above the diagonal. And the lower triangular matrix um, is called lower triangular if it's non-zero, right? If it's non-zero entries lies below the diagonal, right? So we have this here, non-zero, this asterisk here. And then we have a diagonal matrix have all the non-zero entry lying right here in the diagonal. So we then have a first proposition, right? If A has a zero row or column, let's consider then that if a matrix A has a row of zero, has a zero row or column, then determinant of A will be equal to 0, right? Then second, if A, right, is an upper triangular or lower triangular matrix, then determinant of A is a product of its diagonal entry. Okay, then the determinant of A will equal to the product of the diagonal entry. Okay, so if therefore we can have another proposition, right? And this is good for you to know, and it's very important. If A is a square matrix and times n matrix, if determinant of A is 0, therefore the rows or the columns of A are linearly dependent, right? And then if determinant of the same square matrix A is different from 0, then the row or the column of A are linearly independent, right? Now we can also have some other properties of the determinant. For instance, right? We see that if A and B are square matrices, n times n matrices, right? Then determinant of AB equals to determinant of A times determinant of B, right? And then also that determinant of A is the same as determinant of the transpose of, of A, right? So, and then we can also give this one, determinant of A to the power n equals to determinant of A all to the power n. So these are very useful facts that you need to know about the determinant. So let's finally close with this fact, right? And here we consider A to be a square matrix, m times n matrix, right? The following statement are equivalent, right? So the first one is determinant of A different from 0. Its equivalent is that A is invertible. Also, is that the equation Ax equals to 0 has a unique solution, x equals to 0, and that the columns of A form a linear independent set of vectors. Okay, so we clearly believe that this fact will be useful for you when you will be solving a system of linear equation, or where you have to answer the question if a set of vectors are linearly dependent or independent, or when you have to find to determine if a matrix is invertible or not. So we hope that you enjoyed this video, and please do some more practical exercises on this chapter on determinants. Thank you.